Find the centroid of a circular half disk of radius 3. Well, first we draw the half disk. The radius is 3. You can just simply use the upper part so that we can work with the function f of x equals the square root of 9 minus x squared. Remember, the equation of the circle is x squared plus y squared equals r squared. The centroid is x bar, y bar. But by symmetry, since the density is not given, we assume that the density is constant. And so by symmetry, x bar is 0. The line of symmetry is x equals 0. Because of the shape of the disk, we can only guess that y bar is perhaps somewhere between 1 and 2. It is not at 1.5 for sure, because there's more area close to the horizontal axis. Now recall that the area is the integral from a to b of f of x dx. X bar is 1 over a times the moment about the y-axis, and y bar is 1 to a times the moment about the x-axis. The moment about the y-axis is the integral from a to b, x times f of x dx. And the moment about the x-axis is the integral from a to b of 1/2 f of x squared dx. We assume the density is constant in this case. And so in this case, the area is the integral from -3 to 3. The function is the square root of 9 minus x squared, then dx. But we don't need to find the antiderivative. We know that this is half of the circle. So the area is 1/2 pi r squared, but the radius is 3. And so the area is 9 pi over 2. X bar is 0. Y bar is 1 over a times the moment about the x-axis. We have x bar already, so we only need to find the moment about the x-axis, which is the integral of 1/2 from -3 to 3. The function squared dx. But the square root of the square will cancel out. So we have 1/2 the integral from -3 to 3. 9 minus x squared dx. The antiderivative of 9 with respect to x is 9x, and the antiderivative of x squared is x to the third over 3. Evaluate from -3 to 3. If we plug in 3 using the fundamental theorem of calculus, we have 9 times 3 minus 1/3, 3 cubed, and then we minus 1/2, bracket, 9 times -3 minus 1/3, -3 raised to the third power. This is 1/2, 27, minus 3 cubed is 27 divided by 3, which is 9. And then minus -27 plus 9. Negative times negative is a plus. And so this is 1/2, 18, minus 1/2, -18. And so that is 1/2 18 plus 1/2 18, which is 18. And so y bar is mx over the area, but mx is 18, and the area is 9 pi over 2. Simplifying this, 18 times 2 over 9 pi, we get 4 over pi. And so the center of mass x bar, y bar is 0, 4 over pi. Now, if we didn't recognize the symmetry to get x bar equals 0, we can compute x bar just like we did with y bar. X bar is 1 over a times the moment about the y-axis. But the moment about the y-axis is the integral from -3 to 3, x times f of x. F of x is the square root of 9 minus x squared dx, which will give us 0 because the integrand is an odd function. Find the moment and center of mass of the lamina of uniform density delta under f of x equal x squared and above the x-axis from x equals 0 to x equal 2. So first we sketch the graph. We only look at the region between x equals 0 and x equal 2. Now recall that x bar is 1 over a times the moment about the y-axis. Y bar is 1 over a times the moment about the x-axis. Area is the integral from a to b, f of x dx. The moment about the y-axis is the integral from a to b, x times f of x dx. And the moment about the x-axis is 1/2 the integral from a to b, f of x squared dx. We ignore the density because it is uniform. If the density is uniform, the density will cancel out. And so the moment about the y-axis is the integral from 0 to 2 x times x squared dx. The integral from 0 to 2 x cubed dx. The antiderivative is x to the 4th over 4. Evaluated from 0 to 2, we have 1 over 4, 2 to the 4th, minus 0 to the 4th. 2 to the 4th power is 16. 16 divided by 4 equals 4. The moment about the x-axis is the integral from 0 to 2, 1/2 of the function squared, and so x squared squared dx. So that is 1/2 the integral from 0 to 2, x squared squared is x to the 4th dx. The antiderivative of x to the 4th is x to the 5th over 5. And so it will give us 1 over 10 x to the 5th power. Using the fundamental theorem of calculus, we plug in 2 and we plug in 0 and evaluate them. We get 1 over 10 times 32, which is 32 over 10. Simplifying this, we have 16 over 5. Lastly, the area is the integral from 0 to 2 f of x times dx. The antiderivative of x squared is 1/3 x cubed. Evaluate from 0 to 2. We have 1/3. 2 cubed minus 0 cubed. 2 to the 3rd power is 8. 8 over 3. And so x bar equals 1 over a times the moment about the y-axis. The moment about the y-axis is 4, and a is 8 over 3. And so this is 4 times 3 over 8, which is 12 over 8. 12 over 8 is 3 over 2. Y bar is 1 over a times the moment about the x-axis, which is 16 over 5 divided by 8 over 3. This is 16 over 5 times 3 over 8. Simplifying this, we'll get 6 over 5. And so the center of mass is 3 over 2, 6 over 5. We now go back to the graph and locate the center of mass. X bar is 1.5 and Y bar is 1.2. And so there it is, the center of mass. 3 over 2, 6 over 5.